So now we're given the following graph of f of x, graph the following transformations, then write them in function notation. So let's focus on the graph for number 7, okay? For this one, we are moving left 1 and down 6. So what you need to do is take a point wherever. I'm going to start with this one, and we're going to move left 1 and down 6. So left 1 and then 1, 2, 3, 4, 5, 6. Okay, so I know that's where that point is, and then you can just finish drawing the rectangle. So we're there, and then it's up 3, and here is my rectangle. Now again, you can pick any point to start that, and then just finish drawing the shape. So in function notation, left means that is your x, and that would be on the inside. So that would be a +1, because it's always the opposite. And then down 6 is a -6. On the next one, we are reflecting over the x-axis. And basically what we're doing is switching your y's, okay? So your x value stays the same, but your y values change. And if that's easier to think about for you as we move forward, that might be a good route to go, okay? So for this one, all right, my y value is 1, so it's going to become -1. This one, my y value is 4, so it's going to become -4. And you continue that process, 1, -1, 4, 4. Here's my other rectangle. So this one, I totally just decided to do only half the problem. So let's go ahead and move it right as well, and we'll erase that afterwards. So we reflected, but now we need to also move right 5. So I'm going to pick this point, and if we move right 5, 1, 2, 3, 4, 5, here it is, and finish drawing the rectangle. Okay, so this would be your final answer. So if you would like in your homework, you could, oh crap, sorry. You could always do what I just did and do one piece at a time, and then do the other one, and then erase the middle part. All right, so your final answer here, if you want to write it in function notation, the reflection over the x-axis means that there's a negative out in front. And the right 5 means it needs to be a -5 on the inside, because it's always the opposite. So now we're at the point where we're doing a vertical stretch of 3. Okay, basically what happens here is you multiply your y's by 3. Okay, so if my y is 0, 0 times 3 stays 0. If my y is 4, it becomes 12. So we would move up 2 more. If my y is 2, I would multiply by 3 and get 6. So now I connect these dots, and here is my triangle. Now the stretch is always the hardest one to see, because it does actually change the shape of things. So it doesn't look the same because it's going to get stretched out, which kind of makes sense, right? When things get stretched, they change the shape. So keep that in mind. It doesn't always look the same, whereas all these other ones, I mean, it stayed exactly the same. So this would be 3 f of x. And then our last one like this, we want a vertical compression of 1/2. So if it's 1/2, that means I'm dividing all my y's by 2. So again, 0 stays 0, but this one is 4. 4 divided by 2 is 2. And this one is 2. 2 divided by 2 is 1. So then I can connect those dots, right? Now again, I also need to move this left 3. So I'm going to take what I just drew and move it left 3. So I would have this point, 1, 2, 3. This one at 1, 2, 3. And then this last one, 1, 2, 3. Okay. Now, if you can do this process without doing both at the same time, feel free to do so. It might make more sense, and you might make less mistakes if you do each piece separately. When this compression or stretch happens, or a reflection. Sometimes that just adds a little bit too much and it's harder to see. Okay, but in function notation, this turns out to be 1/2 because that's my a value, and then f of x plus 3, because left 3 is really kind of like a -3, so it becomes plus when we plug it in. Okay, so that's the main focus of today, but we're going to take it the opposite route now. So I'm going to give you the function, you have to tell me the transformations, and then you have to do that transformation. Okay, so this might be a time where you pause the video and then take a look at what happens. With this being a longer video, I might cut some of this out and you might just have to check the answer key for it as well. Okay, so for number 7, inside means it's opposite, so that's really a 2, which means right 2. And the outside is the same, so we're moving up 3. So I'm going to think about this as the center, right? Or I could think about this point right here, okay, and move, yeah, I'm going to use that point. I'm going to move that specific point right 2 and then up 3. Okay, so I know that's going to be the top of my circle, and I could do another one, right 2, up 3, put that one, use this one, right 2, up 3. Okay, and if you do this last one, right 2, up 3, you'd be here. Okay, lots of dots, but you would end up with your circle pretty much touching the other one. Okay. And again, you can do that process whatever way makes sense to you. Maybe you wanted to find the center and just do that. That's fine. On number 8, the -6 means we are moving right 6. The -2 on the outside means down 2. So I'm going to take this point right here and move it right 6. So I'm at -2, so right 6 would be at 4, and then down 2 would be down here. I'm going to move this point at 0, so right 6 is 6, down 2 is here. Same thing here with this point, right 6 is at 6, down 2 is here. And then our last one, right 6 would be 8, down 2 is here. And here is my circle. So then we have number 9. Okay, this one means reflected over the x-axis. And then we have x plus 4. Plus meaning technically -4, which would mean left 4. So if you want to think about it as reflecting over the x-axis, these would stay the same because they're on the x-axis. But these ones up here at 4 would now be at -4, because remember, we flip where those y values are, right? But we also need to move left 4. Okay, so I'm going to do that part in green, or sorry, in red. So if I move this point left 4, it would now be at -6. If I move this point 4, it would be at -2. So our new square would be here as a final answer. And then our last one, we have 2f of x. So this means this is a vertical stretch, because that is our a value of 2. AKA, this is just going to double in height. Okay, so that means if I'm at 4, I'm going to multiply 4 by 2, and I get 8. 4 times 2 is 8. So my new one will be all of this. So we just stretched it all the way up there. So remember, stretches, condenses, reflections, a lot of times that changes what it looks like. Okay? And that's the end of today. So we are going to work more with that tomorrow, so keep that in mind. We're going to start really tying it into lines tomorrow, but the basis of it comes from today. So make sure you take your time on your homework and really try to lock in on this stuff.